Hello. I wanna talk today about bottom board swaps. Very often, due to a lot of damage, the bottom board may get damaged and cannot be repaired. There are various phone models and various reasons why you would attempt to do a board swap. For example, I'm gonna do now an iPhone XS Max. This one is prone to break the interposer here around the SIM tray. The problem is the board flexes like this, and it breaks all the pads on the interposer in this area. So if you have 1, 2, 3, maybe you can just pull wires and get away with it. But this case, to be honest, I don't even remember why I have to do the swap. I just wrote on this phone that it requires a bottom swap. I didn't have the part. The client was out of the country, and now I have the donor part, and we're gonna proceed with the board swap. But what I wanted to speak about these bottom board swaps is very interesting because it applies to all phone models. Usually the bottom board has the RF chips and the baseband and the Wi-Fi. When you do a bottom board swap, for example from iPhone 12 series and above, you need to move the Wi-Fi chip also, the baseband chip, baseband CPU, and the logic EEPROM. There's a baseband EEPROM. It's a very small memory chip that it's on the board, and that one, the information from that chip needs to go to the new board, otherwise it will not work. So basically for this XS Max, I'm gonna move the Wi-Fi chip, I'm gonna move the baseband CPU, the information from the EEPROM, and I'm gonna also move the NFC. I had problems with board swaps and NFCs as in there were examples when clients after the board swap, they were not able to add a card in a wallet in Apple Pay. I'm not sure exactly what models they apply to, but for these ones it's 5 minutes extra to move the NFC chip. I'm gonna move it chip, and that's it. I'm not gonna go around it. But the important part I wanted to speak about are the chips that are required and how we get the data from the EEPROM. This EEPROM is a very small chip. Like if I switch to the microscope, I have one under the microscope. It looks like this. It has 4 pins. One of them is 1V8. One of them is ground, and you have a clock and a data. So it's basically a memory chip, but it's so small that, for example, look, I'm getting a toothpick which is extremely sharp, and if I put it near it, you can see now how small that is. It's extremely small. The problem is that usually these chips are underfilled, so you need to remove the chip. To clean the underfill, the chip is like glass, and it's very highly sensitive, and some of them reball them, others don't, just move it like that. But being that small, it's easy to lose it from this tool, and it will just fly away, and then you're gonna search for it for days, and most probably you will not find it. Once you lose the information on that chip or that chip, the phone is gone. It cannot be used anymore for calling. So that's one thing. Another thing is the Wi-Fi chip. Up to the 12 series, so you have from 7 and above, 8, XS, 11 Pro Max, you don't need to transplant the Wi-Fi chip. there's a way around it. So there is some information on the NAND that stores the Wi-Fi chip data. Now, in theory, you can unbind that Wi-Fi chip, because for the moment the Wi-Fi chip is tied to the CPU and the baseband IC. You can unbind it. If you remove the NAND, place it in a programmer, and there's an unbind option. I can show you here. For example, I have a NAND here. It's from, I don't know exactly what model, but basically, for example, in this XS Max, if I was lazy to move the chip, the Wi-Fi chip, I would need to take off the NAND, and let's assume this is the NAND. I'm gonna connect it to this programmer. This is a Mijing P12. Alright, let me share the screen with you, and it looks like this. For example, so let's say I remove the chip, the NAND. I'm placing it in the programmer. It sees it. It's a Toshiba 64 gig chip. And if I do a query NAND info, I will get this information. And here it says Wi-Fi is not unbound. This is actually from an iPhone XS, this NAND. So all I need to do to use any other Wi-Fi chip is to here click unbind Wi-Fi, and the programmer will do its stuff. It says it's complete. Now if I query the data again, it says the Wi-Fi is unbound. Now if I take this NAND and place it on the phone back, it will that phone will accept any other Wi-Fi chip to be worked on. But there's a catch here, so I never do this, because the NAND, for example at XS Max, is right above the CPU. If I remove the NAND, there's a high risk I can damage the CPU, like do bad solder balls or whatever. There's a risk always, no matter how good of a micro solderer you are. There's always a risk to damage something on the core board. So I always transplant the Wi-Fi chips from one board to the other. Again, this is possible only for iPhones up to 12 series. From the 12 series, you cannot do this procedure that I showed you to remove the NAND, because that information is not stored in the NAND anymore from 12 series and up. So for 12, 13, 14, 15, you need to always move the Wi-Fi chip from a board to another. Another reason to replace the Wi-Fi chip is if it's defective. If it has a short or something, you can replace it with another one. You desolder the NAND, you unbind the Wi-Fi, and they change the chip. But again, this works only for models up to 12. If the Wi-Fi chip breaks on the 12, 13, 14, 15s, then you're screwed. You cannot fix it anymore, because there's no way yet to unbind these chips. Alright, so that being said, I have here two boards. This is the original board that had a problem. I don't know exactly what problem. I removed the Wi-Fi, the baseband, and the NFC, and I'm gonna move them back here. But before that, I need a way to copy the data from this EEPROM, because I don't want to risk desoldering it and soldering back to that board, even if it's gonna take me a lot of, well, not a lot, but more time. I'm gonna copy the information from this EEPROM and write it to this one. using the JCID programmer. So this programmer comes with various boards for displays, for Face ID, for a lot of stuff. But the board that has the 7 series display and 11 and XR has also some pins here. Let me put it under the microscope so you can see it better. Let me see if it looks better. Top microscope. Alright, so we're zoomed out to the max. So you see this board has here one V8 line, which we need for power, a ground, and it also has SDA, that's data, and SCL, that's clock. So I just solder some wires there, and I just have them like hanging here. I'm gonna connect these wires to the original EEPROM, copy the data from it, and then write it back to the new one. To do that, there's several options, but if we look at it, this is the EEPROM here on the XX Max. A1 is the 1V8 line, so meaning that I can take the 1V8 wire and solder it to any of these parts. But I don't want to solder directly on the parts here. There's an option you can see on the back of the boards. You have a lot of test pads. I don't know why they are done like that. I think it's some factory thing. But if we look, the 1V8 line comes right here. And if we look on the board, on the back of the board, looks like this. You can see there are a lot of pads there. So basically I identified the pads that I need. I scratched them and I applied some solder on them, and I'm gonna stick the wires right on those pads. See, they are already prepared. So not to lose a lot of time, because I don't want this to be a micro soldering video. I want it to be informational, as in what we need to do when we do a board swap. So let's start with the original board. We will gonna take the information from this board and put it to the new donor one. Alright, so first thing first, I'm gonna choose the 1V8 line. If we look here, it looks that the pin on the back of the board is right around here. I've already scratched it. Let's jump to the microscope. Now if you can see it well. So I'm gonna take, oh my god, one of the wires broke. Okay, one of the wires from my programmer broke. Let me fix it, and I'm gonna come back soon. I'm just gonna pause it until I fix that wire. Alright, so I fixed my my broken wire. Let's solder the first, which is 1V8. Okay, that's good. Now let's look for the others. Which is next? The clock. So clock is right here. Okay, let me switch to the microscope. Let me find the clock line. This is the new line I just created. So it's this one here. Right. And then I know that the data line is the other one that's left. I'm gonna solder that one. It's right here near the clock line. Perfect. And now the ground, I hope this I hope I'm gonna have enough inertia. Yeah, of course it does. Okay, I think that's good. All right. Sorry for the light. Let's power on the programmer. Takes a few seconds to boot. All right. And now here I'm gonna navigate to EEPROM. Click OK. And now it says that it detected the chip 8024C8. It's a 1 kilobyte chip. I'm gonna connect the programmer to the computer. Alright. Gonna switch the screen on the computer. And I'm gonna open the JCID repair assistant. Alright, so this connects to the programmer. I'm going to chip repair. I will click detect. It said that it detected the baseband chip. Click OK. I'm gonna read it. So now this is the whole information that is stored on the chip. I'm gonna save this one. I'm gonna name it (2609). Okay. And I saved the information. I'm gonna disconnect and turn off the programmer. Now the programmer is off. Good. Let me switch the camera. I'm gonna remove the wires. And then I'm gonna solder the wires back to the new board. Let me do it one by one. As I desolder, I'm gonna solder to the donor board. I'm taking the donor board over here. So I have first pin. I'm not gonna look at the schematic, I'm just gonna put them as they were on the original board. Second one was clock, one was data. I really can't see very well because the sun is hitting the window. I'm gonna put the 1v8 line to the new board. Where is it? Here. Alright. And I just have the ground left. Let's see. Alright, so I think it's connected. Good. Did you see anything? Hope you did. Alright, power on the programmer again. So if I navigate to EEPROM now, it sees a memory chip there. I'm gonna connect it again to the computer using the USB. Switch on to the computer. And now I can detect, it says it detected a baseband chip. If I read it, you saw the information here change. So this is the memory from the donor board. We don't care about the contents from here. What I'm gonna do, I'm gonna open the file that I've just saved from the original one. See, it changed again. And I'm gonna write it to this chip. Yes. Okay, and it says here write success. That is good. I can detect it again, baseband, read it. It reads well. So that's that. I can now disconnect the programmer. Alright. This is the old board, the original one. I don't care for it anymore, we don't need it. It's trash. And I'm gonna remove the wires from the new board. Alright. Wires removed. The programmer, we don't need it anymore. We can put it back to its case. So that was everything related to the EEPROM. Now I can just start cleaning the board. There's some flux left on the back where I soldered the wires. I'm just gonna clean it. Alright, that's good. So now I can just proceed with soldering the chips back. So I'm gonna start with the NFC. I don't remember what was the position. Let me see. So if I keep it like this, pin number 1 is lower right. Lower right. Let me have a look here. It looks clean. I'm gonna apply a bit of flux. By the way, I told you in the previous videos that I liked using the Amtech NC559 flux. The thing is that I ran off it, and it's a bit difficult to find the original one. I bought just to try. It seems that Mechanic is doing this flux. Obviously it's called AD559, but it's extremely similar with the Amtech one, so I actually prefer now this one more. It's a bit cheaper. I buy it like cans like this, and I just refill the glass syringe whenever I need it. It's a very, very good flux, so I highly recommend it. Alright, so the NFC chip, it's gonna be bottom right. Can't really read it. Yeah, it's like that. Okay, I need to rotate the board. I'm gonna use a 350 Fortier with a 6mm bent nozzle. 350 because I reballed it with low melt 183 solder. So if you use the 183 solder, you can easily use 350 to resolder the chips back. Okay, so the chip shifted to its position. It's good. Now I'm gonna do the big Wi-Fi one. Let me see. So pin 1 is top. Let me see, you can't really see it well. Let me rotate like that. Yeah, it's better, you can see it all like that. I'm gonna add some flux. So the chips are already reballed. I don't want to just do another video on chip reballing. There's one already there. It would be just a waste of time if you wanna see the one previous. I think the previous one was about baseband reball. Okay, so pin 1 is like that. Okay, so for this one, it's a very large one. I'm gonna increase the temp to 360 and the air I'm gonna increase to 50. I'm gonna hold it with my tweezers at the beginning, just warm it up a bit. See, it shifted. I think it's fine. Okay, so while the board is hot, I'm gonna add some flux here where the baseband chip comes. Just a tiny amount, not too much. Okay, it's perfect. Alright, so let's have a look. Baseband is bottom right. Pin 1 is bottom right. Looks clean enough. Let's see if we can read position. Can we? Yeah, I think. Yeah, that's the one. Have a hair here. I don't know, how does it look? Is it good enough? I think that's it. Alright, I'm gonna go back to 350 40R, 6mm bend nozzle. It's a bit too up. Okay, this is a bit frustrating. Okay, so it's going down, yes, and I can bump it, so it's fine. Right, I'm gonna cool it off with this hand pump. Sorry for the sun blowing here. Right, and now I can get a Q-tip. And clean it a bit. Okay, so I think we're fine. Now what I like to do is to take the multimeter, have it in diode mode, and check a bit the caps around the Wi-Fi and the baseband to see if there are any shorts there. Can you see it? Like that? I think it's better. Alright, let's do a few measurements. Okay, I have here a very low resistance, but it's not a short. You can see it's 0035. The board is still hot, and the problem is that the baseband CPU has some low resistances around. So I'm gonna ignore that. I'm looking for a full short, because if you don't solder it properly, there's gonna be a full short there. Need to pause it for a sec. Alright, so see now that the board cooled off, it went back to 0.115. It was 0035. Okay, here again I have a short, well, apparently, but if we read the multimeter, it's 0065. If we go to the ohm scale, it's 0.1 ohms. And here we have 65. So 0.1, 0.2. Now, going back, this one is 0, this is 0.069, and ohms, we have 69 ohms. Yeah, that's correct. So that's not bad. Go back to diode mode. So this is 0.71. If we look at the schematic, which cap was that? This one here. So this line here, see, it's a bit low reading, but again the board is still hot, so there's no problem with it. I was just looking for the full short, so apparently everything is okay. Good reading. Let's look around NFC. We're fine also around the NFC. So that is it for this one. We can proceed to reball the board. So that's another downfall. If we swap the boards, we need to reball them. So we cannot use the old balls, although on the models that are up to 12. There's a low temp solder on them, so it's easy to work with. You don't have to reball it, and it just works sticking them back together. But in this case, if we switch the boards, we have to reball it. And for this one, I'm gonna use this type of middle frame reballing platform. It's made by Chanli. It's a quite decent one. In theory, there are two options. It's this one that you put the board in. Max. You put the board in, you put this over, you put the solder here, then this board comes over, and you just blow hot air around it until the balls form. Now they are not very reliable because you cannot just blow hot air and have them reballed immediately. I need to work around and heat it slowly, otherwise the stencil will warp. And there's another option. I'm not gonna pull it from the desk, but it's kind of similar. You just put the paste over, then you lift this one, and the balls remain there, and you just heat it up, and it's gonna form the balls. I find this one more precise, so I'm gonna use the 148 solder for this. I already have some from yesterday. I don't need to be very wet for this model of a reballing platform. If I would have used the one that I need to lift the stencil while the solder is still wet, you need to have a bit more wet solder there. So let's go under the microscope and try to apply some solder here. This is the most difficult part, the one that is here near the sim tray, because you tend to put the solder on the sim tray too. There's no problem, you can clean it afterwards. Yeah, that's good. Now I'm just gonna go down. My dog is not very happy. I think he's hungry. And what did I say at the beginning of the video? I said that this is not gonna be a reballing video. Well, it just turned into one. But now that I think of, I don't know if I have videos reballing the boards, the middle frames, as the Chinese named it. I don't know why middle frame reball. It's like interposer reball or sandwich reball. I don't know. Just sounds weird. Middle frame reballing. Okay, let me grab a piece of textile cloth, and then I'm just gonna wipe out the excess on the board. Now again, when you do that lift option with the other stencil that you can't hit directly, you don't do this cleaning, because it's gonna just dry the paste even more. Where is it? Plus microscope, like that. Alright, and now I'm gonna have the hot air set to 350 40 air, 6mm bend nozzle, and we're just gonna do like this for a very long time. I'm not gonna pause it so you can get an idea how much it will take, but I think this is the last one where I'm gonna do this frame reballing on a video. It just takes a lot of time and patience. So I tried various temperatures, air speeds, but nothing worked better than this option, just to hit the board slowly around until the boards start to form by themselves. And if I do it this way, the stencil doesn't warp. There's a problem with this model for 12s. For example, 12 is a very long and narrow board, and when that stencil warps a lot, so I prefer to do the other method for reballing the sandwich boards, the one that I just lift the stencil with the paste still moist there. But the ones that are like more wide, the boards like this one, it's a bit rectangular and wider, the stencil doesn't tend to warp that much, and if I apply heat gradually and all around it, it's gonna look better in time. Let me put it also under the microscope, because we're gonna get an idea how it's gonna look like. We'll see when the solder will start to fall down to the pads, and at some point it's gonna form the balls, but as I said, it's taking a bit of time. Again, I have no idea if this had a touch issue or it had a baseband issue, the phone. I don't really remember. The phone sat here for a very, very long time. I have it, I think, since June or something. Still needs heat. Okay, I think it's starting to get down. Let me zoom it a bit more. Maybe you're gonna see better how it looks like. It is a lengthy process, but I prefer a good reballing. See the ball starting to form, As you can see, I started to move this a bit slower than I did it at the beginning. Yep, so I think we're good. I'm just gonna move it like that. Alright, we're good. Finally, this took some time. Clean the stencil while it's a bit warm. Alright. Let's see how it looks. Okay, so it doesn't look bad. It's actually good. All the balls are there. Perfect, so I'm gonna apply flux. Hope this is still warm. It's not very warm anymore. But no worries, I just need the flux to stay here. Have a hair here. I usually heat it up a bit, but now I'm in a hurry to finish the video, so we'll just have it like that. I like to have a lot of flux here. Okay, good. So now we can take the heater and let's solder the boards back. Let me see, is this the original one? Yeah. Oops. Okay, so I'm gonna try to line this. I think it's decent. Alright, we power on the heater. Remember, this is set to 190 and 240 seconds. It's 190 because it's about 20 degrees off. So I'm setting it to 190 to actually get like 170 degrees to the board. Yeah, and now we can just wait for it. Right, so while that's cooking, these are the Chanli middle frame reballing platforms. I have them from all phone models. They are the ones that I've just shown you, and I also have one that it's well, it was quite universal. It's up to 13 Pro Max, where you can put the board here. Where's the old board? So let's see, how is it? It's like this, access. Okay, so this one comes like this here, and for this one I have a lot of plates. Let me find the access. Is this the one? This is X. This is not. Where's the access? This is the access max. So this one comes here like that. I'm just adding the solder here. You add the solder, but you need to have it a bit moist, so it's on the moist side. Otherwise it won't stick to the pads, and when you lift this one, it's gonna stick to the stencil. And after we added it, I just lift this off, and we're gonna have the balls there. I put this on the heater, and it will just form the balls. Yeah, so there's two options for how Chinese said middle frame reballing, or reballing the sandwich, or however you wanna call it. Nothing is wrong. This is also from Mechanic. Alright, let's see. We're down to 50 seconds now. I think this is already... I don't like it here. So the problem is that this board is a bit bent here, and it's not making a good connection on this side. But if we look at the schematic, mostly everything here is ground, but we have this PMU to system call reset AP token. I think these are only going down on the bottom. Alright, so okay, this is good. Oh, sorry, you can't see it. All right, let's see now.